Getting started with Honeybee. It comes with a geometry. So you should be able to see the geometry. And I didn't update the components actually because this is a 51, but won't be installed before it's 52. And the reason I didn't because I wanted to show you how you can update your file without even downloading, but we can't do it because, as I said, I checked yesterday, and the place that people the school keeps the user objects is not the normal place. I have to check to change the code to work for you, but just for your information, this component should do this. So when you're downloading it once, you should be able to update all the user objects and update any file that you have with the GitHub repository. So you have the latest version. There are limitations, but it does a really good job. And it's so helpful if you have like an old file and then you get a new release of Honeybee or Ladybug, you don't have to go and change it one by one. It won't work on your systems right now, but we will get it to work. So okay, let's check this file. So this file is, you have a geometry. This is a building of interest. This building in the middle, and you have a context, which is the rest. What I do this time for preparing the geometry, I want to have some materials to be assigned to these geometries. So I create some materials. This is how you create a material in Honeybee. So you need a name. And do you remember we talked about RGB colors? So you can take the RGB from a color. But this is not the best way of inputting a number, except you want to do a rendering, like what we want to do here, right? If you want to do a real daylight simulation, you want to put the accurate number inside. But there is a reason I have components like this. So if you check up here for the materials, you have two options. One option is to do it with colors, and one option is to do it with numbers, which is the more typical way of defining materials in Radiance. So you get RGB, and we already talked about this, right? And you need a material name. And the output, again, is not any kind of Python object or Grasshopper object. It's a string. It's basically a Radiance material. And why this thing is a Radiance material again? Because Radiance has so many types of materials that you can define. And from this interface, I'm just providing some of them to you. It's not everything that you can do. So if you get advanced, or if you are an advanced user, you should be able just to write this material as a text and input it here. So it will work the same. So if you have a standard material from somewhere, somebody sending you, or you have another project you already started with another software, as far as you have that material, you can assign it here. Does it make sense? It means something like this. Let me do text. I internalize this data and I connect it here. So if I connect this text here, it's exactly the same as I connect the output of this component here. For connecting this, I need no interface. So if you're using a mixed function material in Radiance, you can just write it here. You have the two material and you write the mixed function materials. Probably some of this doesn't make sense to you, why it's even interesting. But when you get to the process of like doing it over and over, hopefully you will find it handy. So now we have the materials here assigned like this. I assigned colored material to this, and the rest is white. Change the color to whatever you like, so we get different types of renderings, like different images. I mean, I'll do everything in yellow for the morning today. And you can change the name. And this is not good practice in a way to name materials. We will talk about that. So we have geometries here. Again, like I collect all the geometries I connected as Honeybee objects. And just to double check, you can see if you connect this here, it will give you a list of, okay, failed to copy. Oh, are you getting the same thing? Failed to copy the object, returning the original object. You should connect the Honeybee surfaces to this. Or is it fine? It's fine. Yeah, on some systems, this is an Iron Python deep copy issue, which probably I shouldn't even say now. Like, it doesn't matter. But like, it's something happening inside. Even if you have that, it will work fine. No worries. But that's just a double check. So fine. Like, you get it. Anyways. So these are the objects. And now what I need is a recipe, right? For the recipe here, this time I do the image-based again. And the difference is I'm using a different type of sky, which we call it CIE sky. We will talk about the skies. So, and I have this 3D printed sky. So right now, and it was in your reading material. So you should have an idea what is a standard CIE sky. Do you? No. Okay, we will talk about it. Not a good sign. So go ahead and open this, change this EPW file to a valid EPW file. What this component does, it uses this EPW file to find the location, and then based on month, day, and hour, and the sky type, which can be sunny, sunny without sun, intermediate with sun, intermediate without sun, and cloudy, and uniform sky, it generates that sky for you. For now, because we want just render and I want you to see the shadows, we use a sunny sky, right? It's not a climate-based sky. We will talk about it, but I want you to keep in mind, it doesn't mean because you have an input from EPW file, it's climate-based. The only use of EPW file here is to find the location. It just uses the latitude and longitude. So there is nothing here about the weather file. It doesn't read the radiation values from this file, right? It generates a standard file. So just let me select one file path. I go to the Energy Plus. You have Energy Plus installed, so you have access to the weather files. And for the morning, we go to San Francisco. And it should be 7 a.m. there, open. Okay, I just generated the sky for 9 a.m. at 21st of December. I connected the sky here, so it's already connected. You have the sky, you have the geometries, right? The warnings of the components are not well set right now, so if you don't connect your geometries or you don't connect your recipe, it just doesn't run. It doesn't tell you what's wrong, which is not good. We will get it fixed soon, but it should be fine. Right now, what I did, something extra here. One, I said like my first simulation, so I named it. So now this thing is not going to be in unnamed folder. It will be under a folder called my first simulation. And then I put the meshing level to 1, which means I want a denser mesh to happen. And the reason I did that is because this is non-planar surface. And this is non-planar too. So we want to have a better mesh. And here, I won't check my material and the geometries. And the reason I don't do it because I'm doing a render, right? But if you're doing a grid-based analysis, you definitely do what I said last time. You just bring the radiance file out and then check all the materials if it's assigned in the right way. So now I have the run rad to true already. So if I set this one to true and select the view that you like, it should render it for you. Did it happen? Yeah, it's writing the file when you set that to true. Don't connect that parameter, it will take longer. And then it will open up this. No? You're waiting? Okay. and then I'll come. So just here, I got my yellow building. So, like, what I did, so let me turn this thing to false. Oh, this is what I talked about, right? I didn't disconnect the image, and when I set this thing to false, the image is not there, so it makes my grasshopper crash. And let's see how far it goes. Okay, crashed. Okay, okay. Here's what I talked about, right? So you see it live now. So what I have to do is to close this. Save the changes now. Close Grasshopper. Unload Grasshopper plugin. Yeah, I mean, that's a great component, but if you don't be careful, something like this can happen. And it doesn't happen on every system. I don't know, like, I can't find the pattern. On some systems, it just works. On some systems, it doesn't work. Good for you, because many people had that question. I have to do it again. So you put the, I open this thing again. One thing here, you see this is orange, right? So by now, I assume you know that when something is like this, you have to click here and see like what this thing is telling you. It says can't find the weather file at this address. This is an address that I had on my system, like on my laptop. You don't have it. So what you need to do is right click here, set one file path, and you should have an EPW file somewhere. And you can find it if you don't have anything downloaded right now. Go to Energy Plus. Under Energy Plus weather data, there should be an EPW file. And then select one of the EPW files, open. So now this thing is done. You will get in a SCSI file. And again, the SCSI file is an address. So if you have this SCSI file generated at some point, you just connect the address here. And this goes here, analysis recipe. Don't connect this. If you connect this, it will take long right now. We will talk about these parameters. So now that you have this, nothing looks orange, right? Set this thing to run. It will take a few seconds because it's writing the mesh. And because I put this thing to 1, so it's writing a dense mesh, and then it runs it. And if you see, like, I generate the picture once, and then I delete it, and I regenerate it. And why that thing is happening, do you have any idea? I'm sick. What? why that thing should have? Why we're rerunning the simulation 2 times? Like why I'm running the RPEC? I delete the image, then I run it again. I mean, it's kind of. I want just you guys to think about it. I'll show you why. But do you remember like how radiance works? So it works backward ray tracing. Time to talk about a really good resource that I said. This is the Radiance online.org is the place that you want to go for Radiance. This is where the Radiance community put all their stuff. They have a great email list. They are the best community I know in the building simulation, like versus the other simulation tools available. They're just like the best of the best. They're so helpful. And if you have any question or something in any level, they will give you really good answers, and they're all really good experts on this list that you can find. And Greg Ward, definitely, Andy, all of these people, Rob. So this is a great resource to go. And of course, I am here featuring Radiance as a great tool because it's amazing. I think everybody should know about it. And one of the reasons that Radiance doesn't come with Honeybee and you have to go and download it, because I want everybody to know what's happening when you press run, what's actually doing the job is this thing, is Radiance. So there is a community tab here. You just click on the community, and here you can find the workshops. There are multiple workshops. The one which happened at Berkeley, 10th International Workshop, the first presentation by John, he's talking about all this ambient calculation. And I think this is a presentation that every single person should take a look if you want really to run something, to understand the concept of how Radiance works. And this is why I was showing it. And he's saying like lighting simulation is a hunt for light. So this, when you start this simulation, these rays are going all around the place to find the light. So the first time, it's just like hunting. So if they don't see the light, they miss the light. They have no idea where the light source is. It's a cool concept. I don't know. Do you get it? Like, it's a start from this point, and these points have no idea like where the light source is when they start going. So the first time that you run the RPIC is basically like the first time they're going for hunting and getting an idea about the scene. Where are the best places to start for rendering? And the second time that I run it, it already knows about the scene. So we put it in the right place. So it generates an AMB file. If you go down in this presentation, he just shows that. This is what I talked about. Like, you have two different ways, RPIC and RTrace. You do it for a grid test point or you do it for an image. You know, this presentation is online, so you should go and check it out. Every single slide. We won't have time to talk about it like in details. But some of the stuff here you can see how Radiance works and how the parameters changes the way Radiance renders something. So these are the same scene, right? And the same light source, and 80 is set to 32 versus 64. And you see the result of the render is different. It's just normal. It's something that happens with Radiance. So you should be careful about your parameters. I mean, there are, don't get like in a way that, oh, I have no idea about the parameters, so I can't do anything. First of all, there are some default values there, and there are some best practices stuff there, which you can find in the RAD parameters. I'll show you in a second. And second of all, without you knowing, if you're running a grid-based analysis, I'll take care of that for you. So if you put a really low value for running a grid-based analysis, Honeybee component will override that. I mean, it won't happen for the image-based analysis because image-based analysis look bad. So if you run something, it looks bad, you're not going to put it in your final presentation. But if you do a grid analysis, at the end of the day, some colors and say, oh, this is good colors, you know. So I just override that for you. So you can't run a really bad, but you still can run wrong simulations, but like not very wrong simulations. So you will see the concept of overtures down. This is about the AB, like 1 versus 2. So the number of bounces, you see how it helps for a better rendering. And this is a study. This is a section of a room. So this is 2 meters. Here you get the window, 2 meters, 4 meters, 6 meters, 8 meters. And he has test points and every single point here. And when AB is 1, when you have only 1 bounce, see what happens. You get the one near the window, the value is here, which is which is fine when you compare it with AB2 and AB3. And it goes like to the depths of 5 meters, it's fine. But after 5 meters, you don't get the right result, you see. AB2 fails here, but AB3, 4, and 5 is almost the same. But considering the rest of parameters is this. So then he changed the parameters, and you see like you can see a better convergence between the result. Does it make sense what this thing shows you? Can you imagine this? This is a section of a building, and this shows the value of a test point here, right? So you see after 3, they're almost giving you this kind of the same result. This is with more complexity, but here, this is the concept that I talked about it, right? So it runs the simulation once without, and this is with. You run the simulation once to help Radiance to understand the scene, and then say, okay, this was the scene. Go ahead and do it again now. So now it knows the scene better. Just think hunting I think is a good example. The first time you go hunting, I don't go hunting. I don't know, like something like that. The first time you go, you have no idea, like camping, you have no idea what will happen for you. So you just guess best, you do it based on your best guess. But the second time, you know what's really happening. Yeah, I don't let you change the camera, right? When you say run, it does it itself. So it runs it once, it deletes, and it runs it again, right? So it's already set up. So every time you run, everything happens in that batch file. Right. I'm just telling you why that thing happens. Like at some point you don't find, oh, he's deleting this. He wants us to wait more. You know, this is not the case. But I think all these concepts, you know, when you know really what happens in the back end, this is, at least I believe, the way you click is even different. You know really what you're doing. Check this. So now you know why you should check this. Go back to Rhino and this render. So you see we got the image. It doesn't really look great because of the parameters that we set. And here is where you start thinking, okay, I want parameters with a better quality. I want an image with a better quality, right? This is where this RAD parameters comes in. So these components lets you set up the parameters that we talked about briefly. And there are some that will be set based on a quality. So panel, you see when you change something, it's 20 different parameters that this thing sets up. You can have 0, 1, or 2, which is low, medium, and high. And how I came up with these numbers, it's not like me coming up with these numbers. If you do the help, so what I did, I right-click and help. Just copy this address on the top, the RAD side, LBNL RPicked options, and go to that website. Oh, what happened? Apparently the copy paste doesn't work in the help. So you can do this. Just double click on the component, copy it from here. So here you go, minimum, fast, accurate, maximum. And they have notes tell you which option will just affect the rendering time, which option won't, all this stuff for these parameters if you want to get more advanced. And here's the thing, these are the options for RPicked, which is the image. But like not to make it complicated, I'm using the same thing for RTrace, which is when you run it for a grid-based analysis. And for RTrace, I'm taking care of the parameters that you can go wrong. So we will run an RTrace and I will show you. It will tell you that I override all these values for you, that you set up something which is not good. So now, just to see the effect, and it will take a little bit longer, but let's do that. So just do one. Oh, okay, before that, just one thing. So sometimes you don't want to set all the values to the higher value. because you know the case is actually simple, but you want the number of bounces for some reason to be higher. So you can put this thing to 0, and then you can just override the number of bounces, like 4. So what happens here, all the other parameters will be set to the low quality, except this one. So AB is 2 here, right? I override AB to 4. I can override AD if I want, so, and AS or AR, and for some simulations I do, but like that's a different lecture talking about like what are these parameters and how you do it. So I hope that presentation helps, John's presentation. If you have any question, let me know. We can talk about that in more details. So right now, just set this thing to 1 so you can see the effect of high quality, and you can see the effect of time too. And connect it to the RAD parameters, and if you have that thing set to true, it should rerun the analysis. And now you will get more time to really read what's happening here. So I want to have this time to tell you, you know, like you guys should definitely know more than normal people that are running simulations. So I suggest to get used to these command lines. You know, you shouldn't be limited to what somebody prepared for you as an interface. You should be able to go and edit this for your purpose. That's when you really start being a person who can run simulations, because you know what really happening and you can control your model based on what it is. I'm just telling you what happens here. So what happened first was I generated some files, and that files are here. Go to the C/ladybug folder. So there should be a folder for my first simulation, because we named it as my first simulation. This will take enough, so we have time. So there is an image-based simulation folder here. Let's see what we get inside this simulation folder. This is set to not showing the extension, but it's fine. So the first one is the sky. And it tells me, like, this is the CIE sky, sunny with sun, at 21st of December at 9 a.m. Right? And I'm going ahead and open this sky file, which is a text file. So this is what the sky file is. Nothing magical again. There is one line. I write some stuff here, like for just information, like the location, all this. There is one line here basically that generates the sky. It says gen sky at the time, and it gives some information about the location. And this plus S means this is a sunny with sun sky, right? So if I change this thing to minus S, it will be a sunny without sun. If I change it to minus I, it will be an intermediate without sun. Minus U is a uniform sky. C is a cloudy sky. As simple as this, right? No magic. Like, you don't have to do something crazy to change the sky type. Then this was the sky type, and where it is here, I define the materials for the sky and for the ground. Again, you can find more about this in the presentation by John. So you put a hemisphere around your model, and you put a glue, like a glue from the sky as the source light coming from the sky, and another source coming from the ground. This is how basically you put the light. It's again like your renderings. Do you remember how you set up a render? I don't know how many of you really set up renders, but okay, that's not a good example. Anyway, so you're lucky if you don't set up renders. Then you have another one which calls material, my first simulation. So in this one, as you can see it from the name, you have the materials. Again, these are all text files. The reason of having something Honeybee is mainly not to look at this text file, right? But on the other hand, probably the other reason of having something on Honeybee is to generate this file easier, so you can just go through and see what's happening, and at some point you don't need Honeybee. That's all the, like, usually they say when you get really good in simulation, you don't need to run any simulation because you know what will happen. It creates these files every time. No, this is what it uses for simulation. So when you connect and you click, it just says and goes, okay, this is the sky. So copy the sky file here. This is the material. It writes all the generic materials, and if you have another material that you only use in this study, for example, I added white diffuse and I added brown building. These are the two materials that I added. So it just writes all the generic material for Honeybee, and then it adds the material specifically defined for your file here, right? So this is how it does it. So this file basically has all your materials, and you remember this line that we talked about it? It's a plastic, then you have a name, RGB. Go ahead. It just does copy the new generic material here. So this component, it's not like I am copy pasting like bunch of material each time. So it basically checks what type of materials you have in your model, and it generates that in that place. No, you can just write it down there. That's what I'm saying. Like if you generate this thing once and you want to run like more stuff and you don't want to use Grasshopper, you can just go to this folder and just run it. You know, you can edit the stuff and just run it. And the reason this thing works like this is you can go backward too. As I showed you, you can start from this folder and regenerate everything. That's what I want to do right now. Or let's do it for the grid-based analysis so you can see the points comes in too. But okay, we talked about the sky. This is not the same folder. So we had the sky, we had materials. Then you have a batch file, which basically is the file that ran everything. When you say run it, it basically it's like double clicking on this. Don't double click, it will run it again. So right now. And then you have a rat file, which is all your geometry information. Go ahead and open this file too, or I'll just do it for you. So this is what happens. It says the material, this is a polygon, this is the name. I just put like a random name for this. And then it has 12 values, which are the points. It's X, Y, Z, X, Y, Z, X, Y, Z, X, Y, Z. This is a rectangle. Right? So this tells this is a polygon in radians, and this is the material which is applied to this polygon. And where I know what is the properties of this material, inside that material file. Right? This is how these things works together. So inside this material file, I have a material called, where's that? White diffuse, which is this. And how I let know radiance about all this stuff is a single line that I produce this OCT file, oct file. I say like, this is my sky, this is my geometry, this is my materials, take them all together. And then in batch file, I say, please run it. So this is how this batch file looks like. This is about the path, like go to the right place. And then I say, hey, this is the scene together. This is my, this is the rat file, which is the geometry. Then I have the sky file. Then I have the, so that one was material, the first one, right? This is the material file. Then I have the sky file. Then I have the geometry file. Put them all together. And when I put them all together, I can go and say, okay, rpict, which is basically render my picture for me based on these input parameters, and generate the image here. And then I delete that. I delete my ambient file. And then I run it again. Run the rendering again. And when I'm done, I just here do a size change. This is again something in Radiance. You just render it bigger and then you change the size to have a better quality image. If you want to read about this, go to the manual of RPict. Actually, let me show you this. Is it getting so advanced for the morning right now? So I think like you guys should know all this stuff. You know, again, like I don't really care if we can finish everything that I wrote in that schedule. The main thing is you guys know why we're doing everything that we're doing. Then you can go ahead and find it. So if you just search for RPict manual and probably Radiance, this is where you can read about all this stuff. So for every single of these things, if you want to get into it and just like read why this thing happening, and then like why I delete that, why I resize all this stuff, this is all here. There's no kind of like science somewhere else. This is everything. You can have access to all this stuff. So finally here, I just say, okay, make this image smaller and put it in as an HDR file, as an output, and then I exit. If you run something and it gives you an error, let me make a mistake. I just do minus VP, something that we don't have, like VPTT. And here I make the mistake to something. You can set this thing to pause. This is how you basically debug your simulations, right? So you close this. I changed that exit to pause. Now I run this, something goes wrong, but this thing pauses here, right? So I can go here and say, oh, fatal, command line error at VPT something something. You see command line error is something. So you can basically read and see why it went wrong. Sometimes you don't have Radiance installed. Sometimes the path doesn't work. Sometimes you don't have the right to sky. Like all this stuff, you can see it here in this bash file. Make sense so far? You know why we're doing this? Okay. Let's go ahead. Let's talk about the skies. Now it comes down. You can just lay back. Enjoy the image. Enjoy the view. So now you see like it's a little bit better kind of image. You can set it to high to get like a higher resolution, change the size to have a bigger image, like all that stuff. We're not going to do that here. So before saving, remember, disconnect this. And set this thing to false. So when you open it next time, it doesn't run. Yeah, and if you're sending files to other people, set these things to false. Like you open the file, like boom, 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 everything comes up. But just for your information, because I get the files from people and you have no idea if they set it to false or not, this is something in Grasshopper you can do. So before opening the file, right-click here and lock the solver. So when you lock the solver, it means it won't run. It's also useful if you're changing multiple stuff and you don't want each time the definition basically to be re-execute. You just set this thing to lock. Now I go ahead and open this file, and it won't run anything. You see, everything is orange. So I can go and check, okay, this is false. This is not connected. You know, all this stuff, I can check everything. And when I'm sure everything is fine, I can right-click and say, okay, unlock the solver. You know, if your file crashed, like what happened to me, and you had it saved, if you open it again, it will crash. So the way to solve it is just set this thing lock the solver, go ahead and disconnect and fix everything, and then let it run. Yeah, we're getting to high level stuff here.